So an environmental science teacher at a high school with a large population of students wanted to estimate the proportion of students at the school who regularly recycle plastic bottles. The teacher selected a random sample of students at the school to survey. Each selected student went to the teacher's office one at a time and was asked to respond yes or no to the following question. Do you regularly recycle plastic bottles? Hopefully they all said yes. Doesn't look like it. Based on the response, a 95% confidence interval for the proportion of all students at the school who would respond yes to the question was calculated as 0.584 to 0.816. So that means the proportion is halfway between, well, the sample proportion is halfway between those two numbers. They did a 95% confidence interval, so they are 95% confident that the true value or the true proportion of students who recycle plastic bottles is between 0.584 or 0.816. Or another way to think about it is somewhere, but we're 95% confident that somewhere between 58.5% and 81.5% of the students recycle plastic bottles. How many students were in these samples selected by the environmental science teacher? Okay, so a couple of things to point out, right? First, this is a confidence interval for proportions. It says so right away. So that means instead of using the T interval stuff, we're going to be using the Z interval stuff. So that is important to remember. Second, we need to remember what the formula for a confidence interval for a sample proportion looks like. So here, this is going to be a pen and paper demonstration. So the formula for a confidence interval for proportions is the point estimate, which is the proportion, the approximate proportion that they would get. So basically, they interview all the students, and however many of them said yes, that proportion would be that number. And then it's plus or minus a critical z times the square root of that same p hat, same proportion. So p hat times 1 minus p hat, all divided by n. Now the question, and so this part right here, this is what makes up the margin of error, right? So our sample proportion plus this number would be 0.816, and minus this number would be 0.54, whatever it was. So what the question is asking is, what is this value here? What is n, right? Now, at first glance, it's like, okay, well, it's not set equal to anything, so this is kind of difficult, or it's equal to two numbers at a time. That's not really helpful. But if you remember, we can take this part of the formula, since it is equal to the margin of error represented by ME equals this. So what we can do is we can solve this half of the formula for n, and it would look like this, right? I'm not going to go through the demonstration. I've done it in class. I think I've done it on a previous video. It's tedious and I hate it and I don't want to do it. So this says our n, our sample size, will be equal to our critical z, our sample proportion, our critical z squared, that's important, our sample proportion, 1 minus our sample proportion, and then that margin of error squared. So what we need then, in order to fill this out, since we're looking for n, well, we need this p, because that goes there and there. We need this critical z, that would go right there, and we need this margin of error. So we can fill this out. And once we have all that, then we have all the numbers we need. So first, in order to get the p hat, in order to get that sample proportion, what we need is to figure out what it would be. Well, it's just halfway between these two values here, right? It's halfway between 0.584 or 0.816. So it's equal to basically these two numbers added together and then divided by 2. Excuse me. So 0.816 plus 0.584, and I know I overuse parentheses. And then these two divided by 2 would give us halfway between. So we get our calculator out, and there we go. Halfway between equals 0.7. All right. Now to get the critical Z, we just need to look at a little bit of information here. So we know that is a 95% confidence interval. Now, hopefully we remember what the critical Z values for a 95% confidence interval are, but if not, we will have access to our normal table, so we can always just look that up. Now remember, for a confidence interval, for the table you're going to have during the test, remember a confidence interval is between two Z values. A 95% confidence interval is going to be between there's going to be a little bit of shaded area over here and a little bit of shaded area over here. So we have to imagine is that this is filled in both sides. 95% of it will be in between, which means a cumulative 5% will be on either side, which means 2.5% or 0.025 will be on this side and 0.025 will be left on this side. So all we got to do is find the table or find the value in this big gray part of it that gives us the value closest to 0.025 right there. Doesn't have to be close, it's right there. So our Z value then, so there we have 0.025 right there. That is at negative 1.96. And since it's a critical Z, we take the absolute value of that. So we're just going to use 1.96. So for the margin of error, all you got to do is say, okay, well, it's the halfway point between these two values to one of the values. Basically, it's how much it is between 0.7, which is our estimate, to 0.81 or 0.816. Yeah. So we can say, all right, 0.816 minus 0.7, and that gives us 0.116. That's crooked. I apologize. 0.116. So now it's just a matter of taking these values that we just found, the p hat, the critical Z, and the margin of error, and filling in this formula with those values. So I'm going to go down just a little bit. There we go. So n is going to equal our critical Z squared, so 1.96 squared, times p hat, which is 0.7, times 1 minus p hat, 1 minus 0.7 or 0.3. You can put both in, doesn't matter. You could, if you're doing this in the calculator, you can type 1 minus 0.7, it'll be fine. And then all of that divided by the margin of error squared. So all of that divided by 0.116 squared. All right? And then all we got to do is get our calculator and plug those. And there you see our approximate n, or our n would be 59.9, which you can't have 0.95 of a person, so that means we're going to say our sample size was 60. That makes more sense, doesn't it? And there you go. Obviously, when you're doing the actual test, since you're doing most of this on pen and paper, if this is the actual one of the questions that you're asked, I would strongly recommend taking a photo of your work and uploading it, and not just typing this. So just be aware that, don't just write this. They need to see your work. So take a photo of your work, upload your work. So there you go. Given the method used by the environmental science teacher to collect the responses, explain how bias might have been introduced and describe how the bias might affect the point estimate of the proportion of all students at the school who would respond yes to the question. So in order to do this, we have to look at what was actually done, right? This is not a math question, this is a bias question. All right, and remember, bias is something learned about all the way back in Unit 3, which was like October. So the teacher selected a random sample of students at the school to survey. Went into the teacher's office one at a time and was asked to respond yes or no to the question, do you regularly recycle plastic bottles? All right, so a couple things to take notice of, right? So you remember the concept of blinding and double blinding an experiment, right? When you blind an experiment, it means the person who is responding doesn't know what they're getting. And then when you double blind it, the person who is collecting the data also doesn't know what they're getting. And the reason they do that is to avoid obvious bias, right? Well, in this scenario, this is a direct person responding to a survey about recycling to literally an environmental science teacher. Chances are an environmental science teacher probably is pro recycling. So by having that face-to-face conversation, by having that survey take place up front, yes, it's quick, it's easy, you get it done. However, it's clear that, students may lie because they don't want to look bad in their teacher. They don't want to disappoint their teacher. So it could heavily inflate those numbers. So it's likely, one likely possibility is that the true proportion of students who recycle plastic bottles is significantly lower than the amount that was actually reported. So all we got to do is basically type that in a nice, concise way. So there you go. The statistics teacher at this high school was concerned about the potential bias in the survey because, statistics teachers love nothing more than to go around to other teachers and point out flaws in their lessons. To obtain a potentially less biased estimate of the proportion, the statistics teacher used an alternate method for collecting student responses. A random sample of 300 students was selected, and each student was given the following instructions on how to respond to the question. In private, flip a fair coin. If heads, you must respond no, regardless of whether or not you recycle regularly. If tails, please truthfully respond yes or no. The results of the sample showed that 213 of the 300 students responded no. I've skipped a part. What is the expected number of students from the sample of 300 who would be required to respond no because the coin flip is heads? If it's a fair coin, it's a 50-50 chance. So half of the students will have to respond no, no matter what. The results of the sample showed that 213 of the 300 selected students responded no. Based on the results of the sample, give a point estimate for the proportion of all the high school students at the school who would respond yes to the question. If half of the students had to respond no, that means half of the students responded truthfully. And since they were responding truthfully, and the pressure was off them to lie, oh no, I had to say no because I flipped heads, So this is probably a more accurate response. So the results of the sample showed that 213 of the 300 selected students responded no. Well, 150 of those had to respond to no. So quick math. So out of the 150 that are left, 63 of them still responded no, which means, so 87 out of 150 of the students still actually recycled is 0.58. So here, write it as a sentence. And there you go, the end. Great job, gang.